that is so cool. All I had to do was come like 100 feet away from the busy road out here in the woods, and my meter readings have gone down by 30 to 40%. Out on the street, it was around 60 to 65, and back here it's 35, 40, 45. So, oh, but now I smell smoke. Oh, and sure enough, now we're getting some spikes. What we're seeing here is the number on the left is the number of seconds since we began this outing. The next number is our relative pollution index. And in fact, there's smoke coming by, and sure enough, it went up quite a bit. Someone's burning in a yard near here, and it just came through, and now it's going up. Now, keep in mind that out on the road, those numbers were running around 60 or 55 to 65. The third column is the temperature in centigrade, and the fourth column documents when I breathe in and out, whereas in the fifth column describes the breaths themselves, both numerically and in terms of volumetrics. Our LED user interface, we use primarily for debugging the product, but we're also using it for user feedback for breath exercises and people that practice yoga and other things where you want to have immediate visual feedback. The blue light indicates the quality of the air. The brighter the blue, the cleaner the air. And as the dust concentration increases, the blue fades away to black. The green light shows me breathing. So when I exhale, it gets dark. When I inhale, it gets very bright. The red lights are essentially an oscilloscope showing the vibrations of the breath sensor. This is the air quality sensor. It's currently on a long cable that I'm wearing like a tie. It has holes on either side that allow air to passively flow through, and it uses an LED to measure the density of the dust. And by combining the data of the actual size of the breath and the actual quality of the air in that moment, I know exactly how much pollution I've been exposed to in my lungs and can finally draw some conclusions about my air and my health. So we've come back from our trip. All of the data that we collected was stored on the notepad on my iPhone. I'm just going to pick out a file and email it to myself. So basically, while we were out riding around, the conscious clothing apparatus was gathering its own data 1,200 times a second, reporting it in a log file once a second and once a minute in aggregated format. To begin with, the idea was a wearable computer. And the best wearable computer available today on the market is based on the Arduino standard, and it's called a LilyPad. The components that we're using are the LilyPad computer itself, a Bluetooth component, a power supply, 4 LEDs, 1 omnicolor and 3 red, green, and blue. We have a temperature sensor, a push button, and 2 slider switches, and a battery. The back sides of all of the components are smooth, no sharp edges, and all of the holes for connecting the wiring to the chips and the components themselves are all located on the outside, designed to be sewn in together with the wires. And what this basically gives us, if you look in 3 dimensions, is we have essentially a skeleton-like structure made out of the wiring itself, which flexibly holds the components together in a robust and comfortable way. The underlying technology that lets us perceive how the human body moves and articulates and breathes and whatnot is what we call a groove strip, which are these elasticated, knitted strips. On one side, they're made of nylon and lycra, and on the other side, we have a matrix of knitted silver. And the nature of the silver knitting process makes it such that as you stretch it, the knots themselves change geometry, and it changes the resistance within the fabric itself. So by connecting it to an analog to digital converter on board the computer, we're able to perceive in software how much it's being stretched. You can see that when the groove strips are stretched, the log file reports an inhalation and exhalation. When it is placed here where it belongs, it moves with your chest. It fits no matter what shape your chest is. the battery conveniently hangs down. Okay, now I wanted to show how we actually fit these during the prototyping phase. Essentially, these two clips are used to clip the device either onto like a necklace or directly onto the collar of whoever's wearing it. There we go. That's that. This is the air quality sensor, which just drapes around the neck and ends up hanging there. And then the groove strip itself is simply wrapped around the body. It's not tight at all. It's no tighter than the shirt itself. Now, this one goes around the body twice. It stays above the ribs, and if you turn around, you can see that it's just above the end of the rib cage, because this is the part that we've measured as most accurately represents what's going on inside of the lungs. Here, let's turn it on and see how it works. Now, the first thing it does is every breath you take, it calibrates itself. So in the first couple of breaths, the green light is a little uneven as it's calibrating, but now it's perfectly showing through the luminosity of the green when he's inhaling and when he's exhaling. My air, my health.